You know, we spend so much time trying to write code that works, we often forget to ask a really important question. What happens when it doesn't? And look, in the business world, code that doesn't know how to fail gracefully isn't just an inconvenience. It can be an absolute disaster. That's why building resilient software isn't just a nerdy best practice, it's a core business strategy. And I want you to really think about this. When an application goes down, it's never just a simple error message on a screen, right? The ripple effects can be huge, hitting everything from your sales numbers to your company's reputation. So let's get real for a second. What is the actual cost of a crash? All right, so let's break that cost down because it goes way, way beyond a user just having a bad moment. We are talking about real, tangible impacts that can hit a company's bottom line, sometimes in ways you might not even see coming.
Okay, so look at this list. Lost sales? Obvious. A bad user experience? For sure. That reads directly to a damaged brand reputation. But the one on this list that should really scare you? Corrupted critical data. That is the silent killer, a problem that can haunt a business long, long after the original bug is squashed.
And this right here, this is the whole point. It sounds kind of weird to say it, but a program that crashes is, in a way, a good thing. It's loud, it's obvious, it screams, hey, fix me. But a program that just keeps chugging along with bad data, that is a silent disaster, poisoning everything it touches. So failing fast, that's not a bug, my friend. That's a feature. So the big question is, how do we build this fail fast feature into our own code? Well, it all starts with a fundamental shift in how we think. We have to stop just coding for the happy path where everything goes perfectly, and instead we need to adopt what's called a defensive mindset. Defensive programming is literally what it sounds like. You're building fortifications around your code. You're not just hoping the user types in a number when you're asked for one. You're writing code that is fully prepared for them to type in their name, or just mash the keyboard, or enter nothing at all. So what does this mean in practice? It means you stop trusting and you start verifying. You write your code assuming the network will drop. The API you're calling will be down. The file you need won't be there. Because when you assume failure, you end up building systems that can actually survive it. The cool thing is, Python gives us the tools for this right out of the box. When something goes wrong, it creates something called an exception. Now, if you don't do anything about it, your program crashes and gives you a traceback, which is like this perfect little roadmap that points to the exact line of code that broke. Super useful. Okay, so how do we handle these exceptions and stop the whole program from blowing up? We use a safety net. And in Python, our main safety net is called the try except block. Let's see how this thing works. Think about this. It's a super common scenario. Your code needs to read some data from a file. But what happens if that file got deleted? Or maybe someone just renamed it? Well, without a safety net, your program just hits a wall and stops dead. Crash. And the structure is actually super simple. You put the risky code, the stuff that might fail, like opening that file, inside the try block. The except block, that's your plan B. It's the code that gets executed only if something goes wrong in the try block. What's really happening under the hood is that the program's execution literally jumps. The moment an exception happens in that try block, Python just stops what it's doing, abandons the rest of the code in that block, and immediately looks for an except block to handle it. If it finds one, boom, crisis averted. The program can just keep on going. Okay, so that's the basics, but we can get way more sophisticated than that. Beyond just try and accept, Python gives us two more clauses, else and finally, that let us handle the outcomes of our code with like surgical precision. Now this slide is absolutely key to writing professional level code. The else block is your success code. If the try block worked, if you actually open the file, then the code to process that file should go in the else block. Now the finally block, think of that as your cleanup crew. It runs every single time. Doesn't matter if it worked, doesn't matter if it failed. This is where you put essential stuff, like closing the file, to make sure you never leave resources locked up. So here it is, the whole shebang, all laid out. Try is the attempt, accept is the error plan, else is the success plan, and finally is the cleanup that has to happen no matter what. Using this full structure makes your code incredibly robust, and honestly just way easier to read. Now, there's another really important side to this whole thing. So far, we've only been talking about reacting to errors that Python throws, right? Like a missing file. But sometimes your own code needs to be the one to sound the alarm. For example, if your function gets a negative number for a bank transaction, well, that's not a Python error. Python doesn't care, but your business cares a lot. That's when you use the raise keyword to create your own error and stop a bad process in its tracks. Okay, so let's zoom out a little bit. Let's tie this all together. Why does this whole philosophy, this defensive mindset of always expecting failure, why does it actually lead to systems that are stronger and more trustworthy? It's because of this number. It only takes one. Just one unhandled error at the worst possible moment is enough to corrupt your most critical data, to process a financial transaction incorrectly, or to lose a customer's trust forever.
And that's the bottom line. Failing fast stops a problem right at the source. You're essentially building a system that protects itself. This isn't just about preventing crashes anymore. This is about guaranteeing the integrity of your entire system and all the precious data that it manages. You know, this quote just perfectly sums up the entire mindset shift. It's about moving from a place of simple optimism to a healthy, productive kind of pessimism. Because when you assume things are going to go wrong, you build software that's ready for the real world, not just some perfect world fantasy.
And that's what I really want to leave you with. This way of thinking isn't just for coding. I mean, think about it. Project management, communicating with clients, even designing a system architecture. Where else in your work can anticipating failure help you build something that's truly resilient?